Andra's 3 decades of experience in international business and engaging with Asian tiger economies is the foundation upon which he adds value to all businesses wanting to engage with the Asian century. Currently helping businesses and professional bodies understand the intricacies of the geopolitics of trade in a region dominated by China. These insights are shared in his books, China's Belt Road Initiative, The Challenge for the Middle Kingdom Through a New Logistics Paradigm, and as a contributing author, Digital Transformation of Logistics, Chapter 13, Exploring the Digital Silk Road. Please welcome Andrew as he shares his insights on digital supply chain with us today.
In today's episode in our series on digital supply chain, we are going to take a closer look at digital twins and digital twin technology, and particularly how it applies to modern-day supply chain management. As always, we have an international guest list who have been involved in numerous applications and implementation of digital twins and the use of digital twin technology across a number of industrial sectors across the globe. Hopefully, you'll gain from their valuable insights into what is meant by a digital twin and how digital twin technology can be used going forward, particularly in the use of AI, self-learning algorithms, and automation within your supply chain. So sit back, relax, and hopefully you will get some great insights into the use and applications of digital twin technology. Well, welcome back to the program looking at digital twins. I'd like to introduce Shilpa Kakira, who is the CEO of Mara Technologies in Singapore. Her involvement in AI and blockchain and the implementation and innovation in 7 countries and 11 industrial sectors. So she comes along with not just the theoretical knowledge, but a lot of practical on-the-ground experience of introducing digital twin technology as well as the hard tech. She's Global Top 20 Growth Fellow for Goldman Sachs and is author of the book Unlocking Blockchains on Azure. So welcome, Shilpa, and I'm looking forward to your insights and your enthusiasm around this subject.
Pleasure to be here, Andrew.
Perhaps the way to start is looking at digital twins and how they optimize supply chains. One of the areas of concern or confusion perhaps has been a lot of people see the digital twin as being merely for simulations, to simulate. How does it optimize it through this optimized supply chains, through algorithms, learning algorithms, enabling AI and automation?
So basically, digital twins in supply chain clones 2 key elements. We all know that the physical assets in the supply chain that's moving around, and also the operations around this physical asset. Now, when these 2 things are being cloned, yes, simulations are the first step of it. But when this digitally cloning part happens completely, only then the AI can literally learn on top of it. So simulations enable people to do it a little bit manually, but once the training data settles in very well, then self-learning algorithms could auto-predict every move in your supply chain, every node impact. So by that, what I mean is, if a particular manufacturer goes and selects a particular distributor and a particular supply chain with it, then he would know the predictive cost and the loss or the impact that would happen when he's using this with an with an automated AI algorithm that could predict the outcome of using this supply chain. So that would be the foundation, that the digital twins first actually clone to the point that all stakeholders are completely on it. Otherwise, it would be, wrong input data, then wrong output data. So first step is that people have to make sure that the digital twin at different points of the supply chain key in properly, so that there's proper reinforcement learning that happens on the input to the output, what profitability comes over every chain, and what would be the value based on every input. So that would be that is how we could optimize, and we could see the whole transparent calculation of using a particular chain or chain of distributors and logistics in between for it to reach from the core manufacturer to the end consumers. So that would be the magic of digital twins along with AI, if it's done rightly. But that's what I would say, that the cloning or the twinning part has to happen perfectly. I would emphasize on that for the algorithm to do its magic. Yeah.
So how would you ensure security or data security within that system?
So there would be a lot of data, like in terms of IoT sensors that would be put across the supply chain. Now, these IoT sensors and these data points that would be updating, real time to the digital twin needs to be end-to-end wrapped. Now, what I mean by that is that it has to be secured from the IoT sensor's IP address to the central server as well. Now, in case of it's a central server, it is prone to hack, or it could not be fault tolerant as well. That's when blockchain could be looked into, if it's really needed in that situation, that the data is that sensitive that should not be shared out of this particular supply chain. So that depends, and you could use encryption as well as the decentralized ledger then to make sure that there's end-to-end security, as well as proper encryption algorithms put up. But the criticality of the data will determine whether you want to use blockchains or not. I mean, in some cases, it's okay to not use it. So that depends on how critical that information is.
Okay, that's really fascinating. But also what I really enjoyed is your description that the digital twins are more than just a simulation program. And that it talks about the data integrity and the transfer and interface. Now, what kind of return in terms of improved optimization or improved efficiency along my supply chain would I expect to get out of employing digital twin technology?
Number one would be transparency. Now, when transparency comes into picture with all stakeholders of the supply chain, automatically the manual process is a little more conscious when you report those numbers out. So when your ESG factors are checked and they're transparently updated onto a digital twin, automatically the performance parameters are clearly put out there. Second, the person who is tracing this can actually see all the performance metrics very clearly. Now, when he is able to see these performance metrics from the manufacturing point to the distribution point to the logistics and the handling and warehouse handling and everything, then he can see where he could actually improve the profitability of distributing it across the chain. So that would be the second part. Third part is something very similar to the first question. That is, when you use AI on top of it, it lets you predict that if there's a warehouse management that's in a certain country and there are certain environmental parameters that are affecting the warehouse management as well, then there is a higher cost. So for example, I'll give you an example of something that requires cold storage. The cost of cold storage might be very different in different places based on the energy consumption and the kind of parameters that need to be maintained. So this kind of transparency, ability to monitor, lets you predict all of this lot clearly, and also the damage to the goods if it's in a hotter weather or in a very improper environment for the food or a consumable to move from one place to other. So this is the third element, that it lets you predict that what would be the damage on it or the extra cost to maintain the supply chain and maintain the product from one end to the other. So that would be the third element. And lastly, it lets you make decision making faster. So now you're able to read these numbers, then that faster decision making lets you change for your next batch immediately. Sometimes when there are new manufacturers in the market, sometimes there's a huge amount of trial and error, and that trial and error tells them, okay, this is a bad decision. But when we have a digital twin that lets them pre-predict, that if they choose route 1, 2, 3, then they could immediately see and then take the right decision then and there. So I think faster decisions is something that's exciting in this age.
Would you say that that really enables real-time decision making, or is it is there an unnecessary delay because you got the digital twin sitting alongside the mainframe?
So I would say real time, because there are a lot of real time operations that you can monitor from anywhere now. Like even if a technician is doing something wrong with the logistics, it could real time tell the technician that if you do decision A, this is the chance of loss. If you do decision B, this is a lower loss of things. So that decision making as well. But that's like ahead, once it's more, the ecosystem is more mature. But imagine if he could just flash his phone with the problem that he's looking at, and he could just get that predictive value of every decision that he could make. So it has to be real time, and that's the beauty.
It sounds like an exciting time in the sector. What I found interesting is that initially digital twins were used in a port and terminal operating systems, but it seems to be extending to a number of industries now, which they seem to be seeing the benefit. What factors are causing that? Now, why is digital twin becoming so interesting to other industries, and why is the momentum growing?
Yes, this is one of the most exciting things that I personally resonate is I come from electronics, my foundation. So the maturity of electronics has actually led us here. Why I would say that is connect the dots to digital twin is your mobile phone is now very powerful as well, right? Your IoT sensors are much faster in terms of communication with wireless protocols. The cloud distribution network is a lot more accessible today than before. And the computing processes of your phone or any other throughput like of a device is a lot higher. So because of all these factors, it has become cost effective to include this as a part of the supply chain. Earlier, it used to be a huge headache, and that's why, and it would not really be profitable for them to use it earlier because of the higher computing cost and the higher physical server cost. You had to literally maintain a room, keep it cold, and make sure these servers are actually tracking all of this. Today, you don't have to do that. So I think that's why the momentum is gaining. Second is that's what, similar to that example I gave you, that the technician could flash his phone and check what he needs to do. It's so easy. You could even, for any activity that's manual, they could just flash their phone and learn how it's to be done in the most efficient way. So that's what is exciting. And now, I think when I see mixed reality combined with computer vision, it could check whether you're doing the work correctly or not real time. So that real time in combination of good computing power on the edge makes it really useful on field for operations on the supply chain.
That's really exciting, and I can see you're very enthusiastic about the future on digital twins. Look, I think there's a lot of progress still to be made and a lot of industry still to be brought into it. How do you think the rollout of 5G or 6G is going to affect the momentum of digital twin?
Yes, more speed. I think definitely more speed in terms of, exactly real time for sure. But I think more than real time, accessibility of the most, like internal places is also like more easier to communicate with most complex internal operations that are not usually on the internet many times. With 5G, I think that distribution increases and better speed, better data consumption for the AI to learn.
Yeah.
And that would make sure that the AI is also a lot better because consumption of data increases with 5G.
Shilpa, I really appreciate your time and your great insights. I found our chat very interesting, but also I found your insights and commentary on where we're going to be particularly insightful. So thank you very much for your time, and I do appreciate it. And hopefully we'll chat to you again in the near future. I'd like to welcome Chris Kosmala to the show, who's got extensive experience in digital twins. Chris is a consultant on digitization and cross-border supply chain management and logistics. He works with shippers, carriers, particularly to leverage modern technology or management technology to expedite and to give greater agility to supply chain management. Chris has recently returned from the Middle East after giving some of his great knowledge on technology and how to be used and how to use it within the new supply chain management. Welcome, Chris, and many thanks for joining me once again.
Thank you very much, Andre. Glad to be on the show again.
Chris, just before the show, we were discussing digital twins as possibly a solution to what I would regard as the new supply chain management tools, the digitalization. In what way would the digital twin or the digital mirroring within a supply chain system facilitate or optimize supply chain management in the new era?
There are many bits to supply chain, right? So first let's think about digital twin, what it is. It is a virtual representation that mirrors essentially it's a real life counterpart, a physical counterpart, right? It originated from the concept of essentially testing systems that are very, very complex, physical systems that are very, very complex, where we can expose these systems to a variety of situations that we can imply digitally, okay? And essentially measure the reaction or response from the systems that we're testing, right? If you remember, that was used in development of aircraft and aeronautical industry. In supply chains, we're really, really new to digital twins. And that's very important to understand. So where will you see them? Well, when there is a physical unit that ideally you would like to improve either the operations or improve the design of that unit. When you think about those physical assets, then warehouse obviously comes to mind, right? You can essentially say, okay, this is what I'm going to do. This is the nature of the product I'm going to handle. This is the nature of interactions with the product inside this warehouse or logistics center. What will be the best design of it, right? So that's a first thing. So we're essentially simulating a behavior of the warehouse against the product and a work process that will be employed in that warehouse or logistics center. The second more important aspect of the digital twin, beyond the simulation of something that we're going to build or we would like to actually test, is the what I keep referring to as an operationalized twin. And that operationalized twin essentially relies on sensors built into the physical infrastructure, which are telling you actually how it is being used, what is happening with this. And by feeding the data into a data lake, it allows us to develop algorithms which essentially keep looking at the accumulated data and maybe introducing or finding out errors in our process, or maybe suggesting improvements to the process, changes that would convey into higher productivity, into bigger.
Sorry, Chris, I've lost you. I've lost sound. Hello, can you hear me?
Yes, I can hear you.
Okay, no, I lost sound for a minute. Yeah, I wasn't hearing you.
Oh, I'm sorry. Okay, do you want to repeat it?
Okay, so if we could just go back to where you were talking about about a minute ago, you were talking about some of the complications between having the data merging or meeting.
Yeah. So operationalizing digital twins is really the most promising aspect of the supply chain operations, both relying on physical assets as well as logical processes. And by this, I mean that we're watching from sensors. We're collecting data from sensors as the process executes, as the machines execute, and we are learning how to improve usage of these machines, or maybe machines and people who are in our logistics process, by applying algorithms. So this is where the AI is actually used. This is the most interesting aspect, where we can use deep learning, the branch of artificial intelligence, to develop a better understanding of the processes and either eliminate errors or wastage from the process. There's usually wastage is in terms of time, right, to perform certain operations. And the other one is actually use these algorithms also to come up with the better approach to doing something, right? So as we are suggesting errors, so that's one thing that improves the quality, obviously. But how about the new process? So while I started talking about warehousing, it's really the most interesting aspect of digital twinning is in ports, right? Because now we're able to put very cheaply sensors on the water and into physical infrastructure of the port and into physical machinery that is operating inside the port. So we have now thousands of possible data sources, thousands of data points, which allow us to, let's say, improve how we are mooring a vessel, right? Efficiency of mooring the vessel, because that is the time lost, right? Yeah. Nothing happens until all lines are fast, and we can start actually operation on a cargo from the vessel, right? Moving between the vessel and the shore. Obviously, movement of the machines within the yard, we can imagine how to do it better, right? In a port. At this moment, we say, okay, well, we're going to start with machines going this particular route. We're going to paint the lanes for these machines. We're going to tell the people how to avoid the machines. But is there a better design to this? So as we are watching actual utilization of these machines and movement of the cargo between the ship and the shore, or the shore and the ship, our AI is probably going to spot significant opportunities to improve the movement of these machines and utilization of the machines, right? maybe a reduction of the emissions from the machines. And a big thing, of course, improving maybe utilization of the people. And the reason for that is because the workforces in a modern terminals, in a modern warehouses, are actually quite small, and we would like to add robots as much as possible, autonomous vehicles, autonomous machines. So obviously, a digital twin is going to spot the ways to improve that mixed environment where we have people and machines mixed together, and we can designate maybe some tasks that we originally thought that the machines will do to people, or maybe originally assigned to people that we'll actually ask machine to do instead. We can test these scenarios, the what-if scenarios, in the digital twin. We cannot test them in old ways of the Japanese improvement systems, right? Which essentially say, let's observe. Okay, so there is a human observer of another human interacting with the machine or interacting in a process, and then based on this, we do a lot of the whiteboarding and rethinking of how the process, how the movement of the person or the machine can be changed to essentially improve the output of that person or that machine. AI can do this for us much better, right? And it relies on sensors rather than just pure observation with the camera.
So would it be fair to crystallize it as that the digital twin, in a sense, is giving us an opportunity to do real-time testing of our systems and procedures without affecting our baseload operations?
Well, the real-time testing, that's already there. You really, I mean, you can think about this as a digital twin, but that's essentially simulation, right? So there is no really advantage other than just simply confirming your assumptions and or hypothesis that you have about how the work is being performed or how the process is being executed. The much better part of the digital twin is essentially saying, I'll let the algorithm to find a better way of doing something. That is really the promise of the digital twin. The simulation of the physical asset and testing against it or simulating some actions on it, that's essentially 30 years old technology at this moment, right? Maybe even a little bit older. So we probably know everything there's to be known about this. But it's the new promise of AI that is actually, shaping as a significant game changer with respect to how we perform logistics, how we perform supply chain operations, related to the products and to the automation that we're introducing into warehouses, ports, terminals, and transport.
Do you have a feel for the level of optimization that can take place with digital twinning? To what extent would we get a 10%, 5%, 20% improvement in efficiency by blending AI, automation, and human activity within a port operation?
Listen, if you're looking for 5%, I suspect a manual observation, manual testing or manual simulation with the limited tools is achievable without spending money on embedding sensors into every single asset or part of the operation where you can capture some action to feed you data, which then leads to improvement, right? So I would say if you're implementing digital twin, you do not expect 5% improvement. Those things are not very cheap, right? Just the sensors alone and the infrastructure that you need to connect these sensors in real time and the development of the algorithms, this is all very expensive. So you're really looking at a serious changes, let's say 20 to 30% improvements in utilization of your assets or in the productivity of your assets and your workforce. Yes.
That's fantastic. I really appreciate the insights because I think there's a lot of, and as we've discussed in an earlier session, there's a lot of misunderstanding around what a digital twin offers and what it does do. A lot of people that I speak to, for example, as you said already, see it as a simulation, tool. Some basically don't fully understand the business imperatives around digital twins. They see it just as an expense. But if you're going to, sorry.
When you think about this, this is what I'm trying to say. The last, let's say 20, 30 years, people were thinking of digital twins saying, okay, I'm going to build a series of distribution centers, right? Let's say, coverage in Australia or in the United States or whatever, right? Pick a country. Where should I locate them? Now, well, then you test various assumptions, right? I'm going to handle 5,000 trucks a day. So I need the access road capacity. I need the turning space in front of the docks. I need so many gates in so many cross docks, so many unloading, loading docks, and so on and so on. And I need so many machines inside the warehouse to actually effectively move between the racks or the storage areas and the back of the truck. We could do these simulations before. We could have done it, 20, 30 years ago. But what we can do right now is, well, the trucks now have sensors. We can build sensors easily into the doors of the warehouse or across dock. We have robotic autonomous vehicles inside the warehouse, which actually fulfill a number of tasks that before we would be fulfilling with people. Those machines carry significantly more real-time information collection abilities and ability to feed that data in real time, because now we have 5G inside the warehouses, right? Before we had an old technology that was just not working very effectively. But now with 5G, we can transfer big amount of data plus images, okay, and allow a machine or a algorithm to essentially assess them for us, right? That is something that doing mostly manual operations with people you couldn't do, right? Because how do you equip a human with sensors? Exactly. Not really that easy, right? The best you can do is saying, okay, here's your little RFID tag that you're going to have in your badge, and I'm going to track your movement around the warehouse, let's say, or around the port or around the terminal. That's interesting, but that's not effective for improving productivity by 20, 30%, right? It is essentially telling me what that person is doing, but really not much more of how they're bending or how they're reaching for something or so on. So with the machines, I can actually track a lot of these interactions between the machine and the cargo, between the machine and another machine, and so on. And the sensors are right now very, very inexpensive. I mean, most of the equipment now comes in with the microprocessors, with the ability to capture immense amounts of data that we didn't have before. So that's really what has changed from the times where we could just do simulation, where the human was saying, well, okay, let's assume I have 500 tracks. Well, now I can say, no, it's not, let's assume 500 tracks. The data collection tells us that we're seeing on average 433 tracks a day, right? And we're handling them like this. So and by the way, they spend X seconds, minutes, hours being loaded, unloaded, right? By the machines, which actually tell us that they managed to do 16 trips, let's say, between the back of the truck and the storage area inside the warehouse or inside the yard. That level of data generation and data collection has not existed before. So therefore, right now, the simulation is no more simulation. Now it's a real-time evaluation of actually what is happening. And from the algorithm, it can say, okay, let's reallocate the stacks of the product, let's say differently, so the machine doesn't make 16 trips to load the truck or unload the truck, but it only does 14 trips, right? 2 trips can convert into a big savings, right?
Yeah. Right, Chris, perhaps could you explain how digital twins could optimize operational decisions in situations where the physical assets are part, or whether the physical assets are part of the activities or not?
Yeah, a great question. So when you think, we spoke about simulation, right? So essentially, imagine a situation where a 3PL has a chain or a network of highly sophisticated automated distribution centers. Right? They are able to offer a complex third-party logistics services to maybe more clients. Yeah. E-commerce is accelerating. It's creating massive volumes. Our 3PL would like to get more customers. Now, how do you send more volumes to your distribution centers? Well, you can go the old way, simulation, right? So you buy yourself a simulation package. You create a model of your distribution centers, which has a number of docks, number of ramps, number of people working inside the equipment, the storage area, and so on. And say, okay, how can I handle twice as many volumes? Maybe expressed in number of trucks that will be coming into the distribution centers and the smaller trucks leaving the distribution center for a last mile delivery. With a simulation tool, you essentially say, you're a human, you're sitting over there and saying, well, since I have 24-hour operation, what if I shorten the time the truck is turned around, the incoming truck from 2 hours to hour and a half, and outgoing truck from 60 minutes to 45 minutes, right? And you play these what-if scenarios as a human. That's a very difficult way to arrive to a close enough solution, and it's definitely never going to be optimal solution. No? Yeah. Now imagine you have you replace this with sensors and a digital twin. So the same simulation, so the same model of your facilities is inside digital twin, now armed with IoTs. So there's IoTs at the roll doors, there is IoTs at the ramps, there is IoTs on the floor, there's IoTs on the machines, on the racks. And now, rather than saying, well, what if, you let the machine play multiple scenarios on the data that is being collected from the sensor. Okay? Yeah. So it's a little bit, it's not the real time, right? Because you know what's happening in real time sometimes is not indicative of actually what you need to solve. But now the machine can replay numerous scenarios and then actually tell you out of this a recommendation. So let's say maybe you need additional ramps, maybe you need to reduce number of this type of equipment and increase that type of equipment inside the warehouse or inside the distribution centers as they're moving around, moving the packages, unpacking the pallets, repackaging them into smaller units for the vans, delivery vans or delivery trucks, and so on. Similar situation plays out in port, right? Examples here, there are quite a few ports, but I think the most advanced at this moment is Port of Antwerp, where they have sensors essentially on the water, sensors on the berths, and sensors inside the terminals that allows them to make different operational decisions about a sequencing of the ships entering the port, servicing the ships, providing maybe additional services, for instance, like bunkering at the same time as you're trying to unload or load the ship, right? There are some things that are exclusive. Some companies do not allow those operations to be performed in parallel, some do. So you play with these, but you play with this based on the real conditions happening in port, right? So your sensors on the water are capturing the wave situation and the wind situation. Your utilization of the berths is visible from the sensors in the decks. A digital twin, can process this information and essentially determine what's important, what's not important. And then based on this, play numerous games against itself or against the perfect model and essentially identify where do we have gaps, where do we have opportunities for extra time or extra machine to perform additional tasks in the same period of time, right? Now, even more interesting, though, it becomes the issue for processes, right? So now you do not have physical assets. This is the typical association of digital twin. Is that the digital twin represents a physical asset. Here we have a representation of the process. And you'll see this slowly becoming more valuable in logistics. The building digital twin is not that cheap, right? Because it's not just the issue of connecting to the sensors, it's also the issue of creating the logic on the back, which is actually processing the observations into insight, into recommendation. And here we now have advancement of RPA, so robotic process automation. So if you imagine, let's say, a freight forwarder, a very large freight forwarder, or very large logistics company, they can actually capture the observations from the behavior of the people and the bots performing some tasks in the process, okay? In that such a mixed environment, it's very difficult to do the simulation yourself, or express this in Excel spreadsheet or similar, or some very rudimentary simulation tools. The twin can actually watch how people are making decisions, what takes them time, what takes them extraordinary amount of time, what takes them too short, right? Now, ultimately, this business of being freight forwarder or logistics company is all about essentially arbitrage, right? You're sitting between a buy and sell decision. You want to buy as cheaply as possible in a volumes that you can fulfill, and you want to sell it as expensively as possible, or resell as expensively as possible to the shippers. Essentially, that creates your margin, right? That may or may not be restrained by the physical assets of your suppliers, right? The transportation companies, the warehouse companies, the customs, and so on. But there is also blockage that could be occurring inside your own processes. How you process the documentation, where does documentation arrive, who touches it first, what do they do with it, and so on, right? And if you have that mixed environment of person touching the document and a bot touching the document, moving this forward in a workflow, it is much easier to observe that behavior from the digital twin. So you essentially reproduce your operations inside the digital twin. And now you make recommendations and saying, okay, maybe I'm doing a sequence of tasks wrong. So therefore, it takes me extraordinary time to deliver the same administrative outcome, which is a document being actioned or a particular decision being taken. The difficulty in a mixed environment is, of course, that it's very difficult to convince people to register their actions. So, you have to go into very sophisticated solutions where you track people's keystrokes, where you maybe observe with a camera what it is, what they're doing, or they're tired, or they're not tired, and so on. It just becomes a very, very complex observation environment. So the ideal situation is that these companies start deploying bots at scale. So robotic process automation at scale, because that allows us essentially to think about our operation of logistics company or freight forwarder company as essentially a factory full of machinery, right? Full of assets. You're watching what the bots are doing, and then you're adjusting bots' behavior automatically on the output of the digital of the insight coming from the digital twin. But there is one more element which a lot of people forget, and that is operationalizing digital twin insight into change process. Okay, sometimes it is most likely perform better if you have optimization tool that feeds off the insight gained from the digital twin. And what I mean by this, there are packages which deal with planning and scheduling optimization, right? This is mathematical optimization, so this is not AI. You take the best scenarios that the twin conceptualizes, and then you create out of this a plan to which everybody, it becomes essentially your objective, right? And then you tune all your services, all your actions, all your activities in such a way that you perform something in an optimal way. And that's mathematical optimization. We'll decide about this. Right? We've done it in mining. In mining, it's amazing when you do digital twins of the mines. then you transfer the best model of the operation into optimization, and then optimization is both situationally aware, and it's actually adjusts itself as it's going through the day of operations. Digital twin is really not a day of operations tool. So any company thinking of deploying digital twin really has to think about connecting the two pieces, or three pieces in this case: the sensors, or the sensing part, the digital twin, in which you can replay millions and millions of scenarios of better behavior, and then optimization, which now operationalizes fully your ideal plan that you conceptualize out of the digital twin. That's very important to understand.
I think that's a very important element, and I think people often get confused as to what the digital twin, or how to optimize digital twin technology, particularly in getting a fairly or a more robust supply and logistics pattern.
Programs like yours, I think, are very critical, right? Because remember, for many years we struggled with explaining to people that machine learning is not equivalent to artificial intelligence.
Yeah,
it is just a branch of artificial intelligence.
Yeah.
There's significantly more opportunity in digital in artificial intelligence than coming out of machine learning. It took forever because a lot of companies which were doing barely machine learning, software companies who were selling solutions, they didn't bother explaining that this is machine learning and actually what is the limitation of that. They just simply put up AI. We're AI enabled, AI this, AI that. And I think, you know, it took a long time to educate people of the differences and understanding of actually what one branch does, what another branch of AI does, and what the other four branches of AI do, right? And possibly bringing this all together. So programs like yours are really critical to increasing that understanding of people who are buying the technology for the purpose of improving their business.
Thanks for that, Chris. I certainly hope we're cutting through some of the misunderstandings and myths around, particularly the digital and the technology around supply chains. Would you say digital twins becoming more understandable and becoming more popular, so to speak, in terms of finding solutions?
So they're finding solutions in asset-based logistics, for sure. So the large distribution centers run by the largest e-commerce company in the world are modeled from digital twins, right? And then digital twins continues to work on improving those facilities. Their Chinese counterpart does exactly the same, right? In logistics services, the biggest progress around utilizing artificial intelligence and utilizing digital twinning to essentially improve every aspect of operation is probably associated, in my mind at least, with a big logistics provider in China, which is specializing in primarily in serving e-commerce, right? But you will see those deployed at scale right now because the costs are dropping. We have now more people with the skills, so you're not competing for skill sets, for workforce, with the guys who have the deepest pockets. So essentially, as the technology is getting cheaper and the resources which understand this technology and can actually do a lot with it are becoming more available because there is more training, there is more education. I think you will see them finding way towards, let's say, middle-size, big logistics companies, probably still with the assets, and very, very slowly, maybe with the help of business process outsourcing companies, getting into that process execution area. Okay, that's you know, a lot will depend essentially on how these companies view themselves versus the opportunities in a business process outsourcing market.
Look, Chris, I obviously can see why you're a busy man, because your knowledge around digital twins and the use of digital twins is fairly extensive, and I'd just like to thank you very much for sharing your insights and some of the issues that possibly people would need to look at when looking or considering digital twinning. Chris, thanks very much. I really appreciate your time, and I look forward to chatting to you again along the digital supply chain. Thank you.
Thanks a lot, Andrew.
Thank you for joining me on this episode in which we looked at digital twin technology and its application and use within a digital supply chain. In particular, I hope you got some great insights into how digital twin technology can be used not just in AI, but optimization of your supply chain management through automation. Our panelists gave us great insights, and hopefully they have given you great comfort as well in terms of going forward in applying digital twin technology to the digital supply chains of the future. I look forward to seeing you next time, in which we will have another interesting topic along our journey along the digital supply chain. Thank you.